So today, the student will be able to understand the concept of rational exponents in order to simplify given expressions. If you have a rational exponent, that's like having a rational number. And in this case, that just means that we're going to have fractions as exponents. Okay? So here's our rule. For any b and any positive integer n, then b to the 1 over n power is the same as the nth root of b. Now, this part is kind of like has to be put in there. When b is less than 0 and n is even, when b is less than 0 and n is even, a complex root may exist. So this is kind of like a stipulation, like, hey, don't forget, sometimes you have complex roots, but this is really the rule. Okay, so for example, if I have 27 to the 1/3 power, that's the same as having the cubed root of 27, which is 3, because 3 times 3 times 3 is 27. If I have negative 16 to the 1/2 power, that's the same as having the square root of negative 16, which is positive or negative 4i. It doesn't really make sense to have something to a power that's a fraction, and so that's its opposite, okay? All right, so if we simplify 1 over 7, a to the 1/7. So here's what's really happening. You've got a. The numerator becomes the exponent, and the denominator becomes the root. So a to the 1/7 is the same as the 7th root of a to the first power, but we don't need the first power written. The 7th root of a. The square root of w, remember a square root is understood to have a 2 here. So I have w, 2 is the base of my denominator. There's no exponent on w, so then it's going to be a 1/2. A to the 1/3 is the cubed root of a to the first power. The denominator becomes your root, and the numerator becomes your power. I don't need to write the 1, so it's really just the cubed root of a. The 5th root of x, the same as saying that you have x. The 5, the root becomes the denominator. X does not have an exponent, so it's understood to be 1. So it's the same as x to the 1/5. 49 to the negative 1/2. Okay, now, this one's a little different. You know that we are not supposed to have negative exponents. It doesn't make mathematical sense. In order to fix that, we built a fraction, and we moved what we needed to either to the bottom or the top of the fraction, because if you move its location in the fraction, the exponent will change signs. So if I move the 49 to the negative 1/2 power to the bottom, then I have 1 over 49 to the positive 1/2. Now I can do something with it. So just like before, you cannot have a negative exponent. All right, now we can keep going. So 1 over 49 to the 1/2. 49 to the 1/2 is really the same as saying the denominator becomes your root. So I have just a square root of 49 to the first power. The square root of 49 is 7. So really I have 1/7. Okay, for any real non-zero number b and any integers x and y. So this just means that your base, the bottom number, cannot be 0, and you're going to have just normal, like whole numbers for x and for y. If y has to be greater than 1, then you have so again, the denominator becomes your root, the numerator becomes your power. Now, so far we've only had numerators of 1, so we haven't had to write the power. You can write it like this, where you square the inside and then take the root, or you can take the root and then not square the inside, but raise the inside to the power and then take the root, or take the root and then raise the whole thing to that power. This is just a stipulation to remind you that sometimes, depending on what numbers you have, you could have a complex number. All right, so for example, if I have 27 to the 2/3 power, the denominator becomes the root, the numerator becomes the exponent. The cubed root of 27 is 3. So then 3 squared is 9. All right, the denominator becomes the root. Remember, if it's not written, it's 2. The numerator becomes the exponent. And the negative 16, the square root of negative 16 is 4i. If we cube that, then we have negative 64i. All right. And technically, because you would have both. You would have positive and negative. So I'm not sure why I just wrote the negative. But that's the idea, okay? All right, so if I want I want 32 to the 2/5 power. So 32 to the 2/5 power is going to give me, I have 32. 5 is the root, and then I'm going to square it. And that rule says that I could write it opposite this. I could write 32 to the 5th root and just square the 32. So I could square the 32 first and then take the 5th root, but most of the time that's harder. So this is the same way to write it. So we're going to take the 5th root of 32. The 5th root of 32 is 2. Because 2 times itself 5 times is 32. Now I need to square that. So my answer is 4. All right, 16 to the 3/4 power. Oops. I have the 4th root of 16 cubed. The 4th root of 16, again, is 2. And if I cube that, then I have 8. Okay? All right, y to the 1/7 times y to the 4/7. If I need to simplify this, then I know that when I have the same base and they're side by side being multiplied, that really means I add the exponents. So I have y, 1/7 plus 4/7 is 5/7. Now, this is technically simplified. This is an exponential form. So if I'm asked to leave my answer in exponential form, I can leave it like that and it's fine. But if I want it left in radical form, then I can write, I have the 5th root of y to the 7th power, or, oh, that's backwards. That's backwards. I have the 7th root of y to the 5th power, or the 7th root of y, all raised to the 5th power. Those mean the same thing. All right, so if I have x to the negative 2/3 power, I did not mean to write this one on your notes. Get rid of this one. This one kind of brings up an extra rule that we just don't need to know yet, okay? All right, but x to the 1/5 times x to the 2/5. Remember, that really means we're adding the exponents. So I have x to the 3/5. I could leave it like that if I want it written in exponential form, or I can write it as the 5th root of x cubed, or that can be written as the 5th root of x cubed. All three of those are acceptable. Okay, this one's kind of weird. So I have the 6th root of 16 and the cubed root of 4. So I'm first going to rewrite that as this 16 to the 1/6 power over 2 to the 1/3 power. Okay, now I can't like before I could take these x's and put them together, right? Because the base was both x. I can't do anything like that here because 16 and 2 are not the same base, so I can't combine their exponents. but I can make them be the same base because 16 is really 2 to the 4th power times the 1/6 power it already was. I have 2 to the 2/6 power, which is the same as 2 to the, oh, not 2/6, sorry. 2 to the 2/3, okay? Now, bring over your 2 to the 1/3. Now I can subtract exponents because I have the same base. So I end up with 2. 2/3 minus 1/3 is 1/3. So it's 2 to the 1/3 power, or the cubed root of 2. So as long as you get your bases to be the same number, then you can combine their exponents. All right, if I have the 6th root of 4x to the 4 power, then technically there's 2 things happening inside of this radical. So I can say I have the 6th root of 4 and the 6th root of x to the 4th. So split it up, just like we've done that before. Normally we do it with -1, but you can do it with anything. Okay, so now I have, this is really 4 to the 1/6 power and x to the 4/6 power. All right. Now, I can simplify the 4 if I make it a 2. So really we're just simplifying. 4 is 2 squared. That's to the 1/6 power, so times. So really I have 2 to the 2/6 power, which is the same as 2 to the 1/3. And then my x, 4 over 6, is really 2/3. So now I have both of them with a base of 3. So I can say this is all really inside of a cubed root 2x squared. So you just simplify as much as you can. I knew that 4 could be simplified, and so if I change 4 to 2 squared, then I can multiply the 2 and the 1/6. Now I'm back at a simpler fraction, and so instead of raised to the 6th power, it's only raised to the 3rd. So that's why we consider it simplified. All right, last example. This is like having 4 to the 1/4 power over 2 to the 1/2 power. Okay, again, I can take 4 and make it 2 squared. The 2 times the 1/4 is 2/4, which is really 1/2. So it's 2 to the 1/2 power over 2 to the 1/2 power. But if I have the exact same thing on the top and bottom of a fraction, we can just say that it's equal to 1 whole. That's it.